class. Today we're going to continue on with Chapter 3, which deals with heat. And continuing on from your worksheet. By the way, this is Miss Rueckert from Pre-AP Chemistry. Section 3.7 in your chemistry book is calculating energy changes. So we should know energy has no mass, but it does take up space, so therefore it's called matter. And we have different kinds. So we're going to deal with thermodynamics in this group. Thermo means heat, dynamics is the process of, so the process of dealing with heat is thermodynamics. So thermodynamics is a study of energy, and we normally look at the energy in this case as being the heat. First law of thermodynamics is the energy of the universe is constant. The energy of the universe is constant, which means that everything on Earth and the universe is going to stay the same. So when you change heat, something gains heat, something loses heat. So that's just the way it goes. So energy can change forms, but what we have is what we get. So we're not going to create anything new. We can only change forms of energy. Kind of like the conservation of matter. Matter cannot be created nor destroyed, but it can be changed. So energy cannot be created nor destroyed, but it can be changed in different forms. Oops. Sorry. So our question was, would it take longer to heat 1 gram of water at 1 degree Celsius or 1 gram of gold? So if we look at this, it's the amount of energy needed to raise the temperature of 1 gram of substance 1 degree. So it's asking you what would take longer, 1 gram of water or 1 gram of gold. We'll chart between water and gold. Water is 4.184 joules. Imagine that. That's where that conversion came from. And gold is 0.13. How much energy is going to take? It's going to take a lot more energy to heat that 1 gram of water than it does gold. And that's why lakes, specific heat of lakes, are actually pretty high. So that's why it takes a long time for a lake to heat up in the spring, and it takes quite a while to cool down in the fall. So here's an equation for you that we probably should write down. How do we calculate energy or heat for a reaction? Is we have this equation. You don't have to write this one down yet, but it's basically telling you energy or heat is required, which is equal to Q, is equal to specific heat capacity times the mass times the change in temperature. So here's mine. Q is equal to MC delta T. Your book calls specific heat with an S. I've taught about five different books now, and college chemistry calls it a C. So for my class, we're going to call it a C. So Q is the energy required, the heat. So Q relates to heat. M is mass. C is specific heat. And that delta sign, that triangle means change. Delta is temperature. So Q is the energy or the heat required in joules. M is mass. We're always going to use grams because that's common in our labs. C is the specific heat. Now note the unit here. Joules per gram degrees Celsius. Hence, that is why the Q comes out in J's, mass must be in G's, and our temperature change must be degrees Celsius. So delta T, again, delta means change, so change in temperature. So normally what we're dealing with, the equation of calculating heat, is if I heat water up 10 degrees, how much energy does that take? So I'd have to take the mass of the energy, know the specific heat is 4.184 joules per gram degree Celsius, and the change in temperature would be whatever I set it at. For my case, I said heat at 10 degrees, so it'd be 10 degrees.